Hey guys, welcome to my stream. So, I have no idea really what I'm going to work on tonight. But, that's alright. We'll figure it out. So, at the top of every stream, I like to start off with things I may have worked on since the last stream, which was only a couple nights ago. I did do something. So last stream we worked on, I think it was this one. Yeah. Debugger, make instructions tray store memory accesses and display them when showing tray. So that's basically what we worked on Monday night. So basically we have this circular buffer and we're storing instruction tray stuff, and what we did is we stored in there the memory accesses, whether the address and value, and whether or not it was a read or a write, and we print those out. So as an example, any one of these in the trace here, when you see like this kind of form here, like let's take this instruction here where we do negate 1. And so what that does is it says at address D001, we want to take the value that's in there, negate it, and store it back, right? And so what you see here is, in fact, that this instruction caused a read from D001, which was hex 38, and then we stored back hex C8, which should be the 2's complement negation. Anyway, it should be the negative value for this. So that's pretty cool. And okay, so what did I do after that? So one of the things that was bothering me, and I talked about this at the end of last stream, was that we still had this, maybe I can show it here. I had put this to do here in my print op that said don't pass the memory bus to print op. Instead, make it print the hex instruction directly from the instruction struct in the trace info. So what this is basically is that I did all this work so that when an instruction executes, just before it executes and just after, we store basically enough information for us to be able to then later on do a trace, like show the trace and show all these instructions and be able to decode or disassemble the instruction, but at some point later in time. But then when we print here, this is the printing part where we say, okay, I want to show that instruction using the trace info. We were still accessing the memory bus redundantly. This was a totally redundant access because we had already accessed it in order to store the trace info, and we were accessing it again. And so what I did the next day, which was last night, is I fixed it basically. So I changed the code a little bit. So in the instruction struct, what I did is I kind of went with the idea of what I was doing before, which was I was storing just up to 3 operands. Now what I do is I store 5 op bytes, basically the max 2 for the opcode and plus 3 for the operands. And then I store a first operand index, and then rather than accessing operands directly, I have a function called getOperand, which knows to read from the op bytes from the very first operand index plus the index you pass in. So that basically allowed me to store everything I needed, and I don't need to access the memory bus anymore. So in read instruction, this changes just a little bit the code, so that what I start off by doing is just reading I just actually read all 5 bytes starting from the op address. So I just read all 5 bytes from the memory bus and store them into this op bytes array. After that, I figure out like, what is this, a page 0, page 1, or page 2 opcode? And that basically means that if it's page 0, it's a 1 byte, and if it's page 1 or 2, it's 2 bytes. And that gets me the opcode, and I increment this opcode index here. And then once I've done that, I can store the CPU op, the page, and I can store the first operand index, which is the opcode index plus 1. So yeah, 0, yeah, plus 1, exactly. And then after that I return the instruction. And then everywhere, all the rest of the changes is instead of accessing operands directly, I use the get operand function. So yeah, that basically that's the whole change. And then and actually that's not the whole change. So yeah, all of these, there's a lot of little diffs just for the change from operands to get operand. But then this is actually the whole point of the change. It's right here. Well, actually it starts a little bit lower, but anyway, we can start here. Disassemble op no longer takes the memory bus here. It doesn't need it anymore because we don't need to. All we were using it for at the end of last stream was to read the memory bus to print out the instruction in hex. And now I have what I need out of the op bytes. So I just, instead of reading from the memory bus, I just read out of the op bytes array here. So that takes care of not needing the memory bus anymore. And then finally there's just a call here, print op here. So I'll also remove the memory bus parameter here, and I just call disassemble op without it. And that's that. And I could finally remove this to do, and I could also remove the memory bus set callbacks enabled false true bit here and not pass the memory bus. So that just cleaned up everything. It's faster, it's more efficient, and does what we want. So that's pretty cool. And I just have a small change here. This is just about formatting, because when I output the values, the writes here, usually I have something that came before it. So like for example this, and then I have this, I insert a space, and then I do this, insert a space, and I do this. And that's fine, except if I don't have a comment, then I don't really want to insert a space. So like for example here, I want it to be the very first thing. So I just put a little code here that's like, do I put an initial space? Well, I do if the comment is not empty. Otherwise I don't put an initial space. And then here I just have some formatting to stick in that initial space or not. So I'm just gonna check that in. What is this here? Oh yeah. Yeah, I was just reverting a change I don't need in memory map. I actually had checked in this change to memory map we did on stream, but I realized I didn't need it, so useless change to memory map. And let's commit this as well. Debugger, don't print initial space for memory accesses if it's the only thing in the comments. All right, cool. So this is pretty good. One thing I was thinking about, and I'm not sure I'm going to work on it just yet there, but I was thinking about this feature, you know, this having this trace buffer in memory with all this information. The very fact that, let's see if I can get to instruction here. The very fact that we store for every instruction which CPU op it is, and like basically we store, actually not just the instruction, sorry, the instruction trace info. This is the important bit. So for every instruction we store the instruction. We also store the state of the registers before and after we executed it, right? We store how many cycles it took. We also store all the different memory accesses that it made, right? And so there's a lot of information. And I was thinking about how with this information, we could totally like create a simple query language to do like queries on the instruction stream, right? So like, say we're debugging a ROM and we want to understand what's going on, and we could, with this I could say, you know, show me every instruction that wrote to this address, right? I could be very specific. I could say, show me every instruction that writes this value to this address, or every instruction that reads from this address, or reads and writes, whatever. I can say, show me any instruction that changes the state of a register from, you know, from, or just change the state of a register. Like, does one write or modify a register? So, because I can do that with the pre and post, right? So we have so much information here. And I think that's pretty cool. And I was just like imagining, you know, like, I don't know. If I could just open Notepad here. It's like I was imagining right now I just do like trace, you know, 1,000. Maybe I do like trace query or something, TQ. And I'd be like, show me, you know, TQ, and I don't know, like, what would it be? It would be like memory access. If I do like MA, then maybe put like some, you know, instruction. Okay, like let's say MA would be any access, MR would be memory read, and MW would be memory write. I don't know, something like that, you know? And I would execute this, and then it would basically show me all the results from the very beginning of the circular buffer till the end, in this, like, for every instruction that writes to this address, you know, show me that in the output. So it'd be like this kind of output, but for that. So I think that would be really cool. And I was also thinking, you know, I would be able to specify optional arguments for, like, you know, n 1,000. Same idea as here, right? So saying like only show me this, but for the last 1,000 instructions. Because if we have a huge, like we have 100,000, maybe it's going to be really long or really slow, or we're just not interested in, you know, from the very early instructions that we've stored. So that's one idea. And actually for this, one thing I don't do right now is I don't store or show in my instruction stream like the I was thinking like it would maybe be interesting to show like which instruction number this one is, you know, like if I was to number every instruction that ever gets executed and just show a number, that might be useful when doing queries, because we'd be able to see like how much distance between each instruction there was, you know, because right now we'd get like no sense of that when we'd show the results here. The only thing about that is that that number is going to grow really, really fast, so that's a bit unfortunate. I mean, I'd use hex to, you know, compress it a bit, but still, you know, we'd get hundreds and hundreds of thousands, like millions of instructions, and it'd be pretty large value. So it would take some real estate on screen here, but still, I think it would be useful. Have like a knot in my. I think I got it. Or did I make it worse? Yeah, I think I made it worse. Anyway, so that's an idea. I'm not sure I'm gonna do that just yet. I thought maybe I'd do it like as soon as I need that feature. You know, like as soon as I'm debugging something, I'm like, you know what I would need right now is to know how many times this thing was written, and then at that moment I'd implement that. But just the idea that I can do it, doing queries on traces, I think is pretty neat. All right. So, what else? Where is my trusty to-do list? Here we go. Oh yeah, lots of stuff. Okay, so this is done actually, the ring buffer. Oh yeah, that's what really important for. So these are all these trace ideas here. Oh, so this is done. The scoped exit bit. Did that. Add command to spit out buffered trace to a file. So this, definitely I need this. Like if I don't have the query language, I definitely want to be able to just do searches through the trace. And you know, the easiest way to do that is to dump the trace to a file and then just open it in my editor and just do finds and regex and all that. So I mean, that's probably what I'm going to do for a while until that becomes less useful. Look at how we can fix the comments. So this I did last stream, so that's done. Oh yeah, that was just something that kind of bothers me about my current debugger interface. Like when we run this, in my help here, I have like these commands like trace and color that toggle whether trace is enabled or color is enabled. And I kind of don't like that. I'd rather be able to do something like toggle trace, you know, and toggle color. This way it's just one command, toggle. And yeah, in fact, what I would really want is a bit more than that. Like to be like toggle, and it'd be kind of like set or unset probably. So like set trace, unset trace. Like so set, unset, toggle, the 3 commands that would be able to take these strings and just basically set these flags on or on. And then that would allow me to actually use trace as the long form for T. Like kind of like the way I have S and step and C and continue, U until. T would become, like where's T in here? Did I even, yeah, T num ops here, and it would become T pipe trace or something. But that's really minor. It's not super important. I'll do that like off stream or something. There is one thing I kind of wanted to do here, that I'm looking here at the mapping of game ROM to overlay image. So one thing I did for overlays, if we go back to the GL render here, is I have this like load PNG texture, and this function makes use of, yeah, it's over here, load PNG image. So this here makes use of PNG, libpng, in order to actually load it, and I have to like get this really crappy code. I honestly, you know, really don't like libpng. It's like a super old C-style library with like set jumps and stuff like that. Not a huge fan of it. And also I don't like the fact that just in order to load PNGs, I had to bring in libpng and what was the other one? zlib. And so like both of these dependencies have to be brought in just to be able to load PNG files. And that's a bit annoying. If I go to my CMake lists, right now I depend on SDL2, OpenGL, glue, and GLM, and then PNG, and it's implicit that zlib is also required, because when you find this, it looks for zlib, and imgui. So, you know, it's quite a lot of dependencies, and I just thought maybe I could get rid of PNG and zlib by making use of, let's see if I could find it. What's it called again? There's a header only image loader that supports tons and tons of formats. What's it called? Oh, header only image load library. Oh, this is it. That's it. STB. So for those of you who don't know, Nothings is this guy Sean Barrett. He's like this legendary game programmer, and actually he streams as well. If you look for Nothings on Twitch, so yeah, he's pretty cool, and he's written a whole bunch of these like single header. He says it here: STB single file public domain libraries for C++. And the idea is you can just grab any one of these headers, and I think they're all completely independent. Let me see. So he has one in here for image. Okay, so here it is. I actually haven't looked at this yet. I just kind of read about it. So public domain image loader. So that's it. The idea is that in one of your C or C++ files, you just define STB image implementation before you include this header. So that's just in one of them, and that's going to basically bring in the chunks of like the stuff that would be in your C or C++ file, the implementations of the functions. Otherwise, when you include a header without defining this, you get the header part, right? All the declarations. Yeah, he shows it here. Oh, that's interesting. It says you can define these macros to avoid using malloc, realloc, and free. What does it use instead? Oh, I suppose you define them to your own. Oh, yeah, okay, you define them to your own. Right. Makes sense. And in fact, this guy supports JPEG, PNG, TGA, BMP, PSD, which is crazy. GIF, HDR, PIC, PNM, animated GIF. Oh, okay, no, not quite yet. That's pretty cool. So there's the header guard. And then here you can see, right, like it doesn't include anything else. It includes stdio, but no other header files. So it's really completely on its own. That's kind of nice. And I'm certain that this interface is a lot cleaner than the one from libpng. So that's something I might do. I'll definitely put it in my notes. So yeah, okay. One thing I was thinking I'd do really quickly is SDL engine. Like right now when I run my emulator, let's say I have my focus in the game window. If I do Control C from here, it doesn't break. But if I do it here, it breaks into the debugger, right? And I just thought I should be able to hit Control C even when I'm focused here and have it break into the debugger. So let me see how hard that would be. Yeah, one of the problems I have with that is right now I don't really have a way to pass information, like high-level information of these kinds of actions down to the emulator. So I would need that. Right now I have like this input object, and in update I pass frame time and I pass input. So we go to update here, and then here you can see I'm doing debugger update and I pass it the delta time in the input. So ideally it's in here that I'd be looking for the Control C, you know, like, or like passing in a command that says, hey, I wanna break here. I kind of like was able to get away without having to go into there for pause, because basically pausing is just not running certain functions. And same for turbo. So these are two functions where I'm like querying keyboard keys, you know, key presses by scan code here. And because none of these have to actually go into the emulator to communicate what it's doing, I kind of got away with it. But for something like the break, I think I would have no choice. Basically in the debugger here, I'd want to say like if the if we detected like a Control C or a break from the outside, we want to set break into debugger equals true. Right now the way I've done it for the console is here. When we initialize the debugger, we use the set console control handler, which is basically a little wrapper I wrote that is when you do Control C, that's the handler that gets called, and then in there I pass it in this lambda that sets mbreak into debugger equals true, and then just returns true. So yeah, that's fine for the control C bit on the console, but it's not fine for if I'm on the window. So how do I want to do this? So that's it. In my engine client, I have this notion of a display, which represents really the Vectrex display, and that's the thing that the emulator uses to clear and draw lines. In fact, I don't even think I use clear anymore. Like if I was to take this out, would this even build? Oh, actually I do use it here. Yeah, so the only place I'm really clearing right now, yeah, technically I wouldn't need it, because I could just clear, I could just like expose a clear on the GL render itself rather than do it through the display. But in any case, it doesn't really hurt. So yeah, I have this display. I have this class called input, really kind of generic, but this is more like joystick input. So I should probably give it a better name at some point. And then we have the iEngine client, and then that's basically like what we implement in main. Over here, the Vectrexy itself is a iEngine client. So what I'm thinking is maybe another data structure that we pass to update. And like this data structure would be something like, I don't know, like I don't know what to call it. It's like events, you know? I want to pause, I want to break, you know, like an event that we pass through. And then I would have like a vector of these events, and then the client of the engine client itself there, the Vectrexy, could then process those and do something with it if it wants to. That's sort of what I was thinking. You know, so like a way for us to pass down like certain events that the engine captures down to the emulator. Something like so for now we'd only have one, let's say, break into debugger. Something like this. Oh, actually, it's not really a class, so I won't be able to forward declare it here like I've been doing. Kind of getting away. I've been getting away with forward declaring in debugger.h, but at this point, yeah, that kind of sucks, eh, for forward declares. But you know what? It's not such a big deal to include. Where is it? So we'd have these events here in STL engine. So now we need to pass MU events down here. For now, we'll just pass something empty. Okay, so this should build. Except for the unreferenced formal parameter. And then like in here, before we even start, first thing we do is we'll say, like, let's process all the events. It does not work. Then I call it type. Inaccessible. All right. And then here we'd say break into debugger equals true. So we've passed it down, we've handled it. Forgot to pass it down here. Alright, so now in STL engine, we could check to see if Control C has been pressed. So let's see if we can do that here. I don't know if I can check control this way. Maybe, oh, okay, there's like, because this is scan codes, I really should stop using scan codes. Let's say left control, and, sorry, if the left control is down and CL scan code. I don't know if the left control thing is going to work, because I know I'm setting these keyboard states. I'm setting them. Where am I setting them? Yeah, key up and key down. I don't think we get a key up or key down for control, so I might have to do something else for that. If I want to use emplace back, I actually have to add a constructor there. Okay, so I think this will not trigger because, like I said, I don't think the left control... Oh shit, it actually works. What do you know? Okay, so let me do that without putting a breakpoint. Oh, I think I'm stuck in an infinite loop of this. Yeah, I need to actually remove the events when I'm done. Oh, but no, I'm actually recreating this. Interesting. Let's see here. This pushes it back. We end up over here, and I have to do continue, and there it is again. Is that because it didn't get a chance to refresh? But the post frame here should have cleaned it up. There's the post frame keyboard update key states. Actually, I should get which scan codes these are. 224 and C is what again? 6. So if we take a look at keyboard, M key states. LMs of 224 and LMs of 6. All right, you guys can see that? Yeah. So we've got down is true for both of them, press is false. I'm wondering, is this like the first time I use, if I press control, okay, so definitely control causes a key down, or a key state change anyway. And then I come in here. Okay, you know what I need to do is I need to go into debug, because I can't step into any of these. This must just be like a small bug in my keyboard handling, I think. Okay, so there's control. So I grab the key state for that scan code, which right now says false for down and false for pressed. Sure. It is a key down event, so I'm going to set pressed to true based on the fact that the last key state was not down. So the first time we just pressed it, and key down becomes like this, and I hit F5. And now, what are we getting here? This is, it's again left control. So down becomes false. Okay. So it's as if the fact that I break into the debugger, maybe this event gets lost. That's what I'm afraid is happening here, because the focus is taken away, right? When I said break into debugger, I guess. And also, actually, what probably is happening is we're not pumping the event loop anymore. Ah, that's what it is. But then we pump it after we resume, so it should technically have gotten the control up. Yeah, it looks like it got eaten. You know what? Let me actually make sure I'm right. I'll just log the keyups and the keydowns. Was it type? Key sim scan code, okay. I'll just separate them now so we know what they are. Yeah, I have the problem of the flushing not occurring. Let's run with color on, because I know with color enabled it immediately flushes. So this key down, key up, key down, 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 up. And if I do Control C, see, we got the key downs, but we did not get the key ups, even though I released. And if I do continue, they're completely, oh, interesting. Eventually it processed them. Control C. 1, 2, 3. Let me see something. You know what? Okay. Let me see here. Oh no. Oh no, we are handling all events. We're saying while we are still polling events, handle all of them, and then once we're done, then we continue with our frame. So why wouldn't it be already in the queue? Like, it's really surprising. I do Control-C. If I put a breakpoint here on the poll event, and I do continue, here it would say, I've got nothing. F5, continue again, it's going to say, I've got nothing. Continue again, and then this time, still nothing in this case. Continue. That's very strange. And then eventually, if I just keep running it enough times, oh, we've got an event to process. Well, if we consider this to be a special case because of the whole focus change, you know, we can fix this by like grabbing one of these and just undoing the state. Yeah, in fact, it won't let me because it returns a const ref, which is correct. Let's do it this way. Or maybe better yet, let's do a reset. And then all we'll do there is we'll just do this. That'll set it back to false, false. And we'll do it on both. X. Focus to the console window. These, we don't get the up events for these keys right away. So continuing from the console doesn't work right away. No, so continue from the console. So continuing from the console ends up breaking back into it again. So let's just see if this works. Yeah, so that works. So we're running, Control C, we're in here, we can step, we can trace, continue. And that's the only thing, is that we don't get the focus back here. But maybe that's not such a bad thing. This allows us to... Actually, I kind of would like the focus to come back there. Could I do that? I suppose I could. Technically speaking, whatever I do is going to be a hack, that's for sure. But it would be something like, if I knew that we broke into the debugger, that. Let's see if this actually works. Doesn't seem to have worked actually. We do set the focus here, but that doesn't seem to do the trick. Okay, you know what? It doesn't matter. This is less important for me. we don't get the up event, the key up events for these keys right away. So continuing from the console ends up breaking back into it again. We avoid this by explicitly clearing the state of these keys. Okay. Yeah, it would be really cool, like, if I could fix the, you know, like, it would be really cool if, like, hitting continue here would immediately go to here, and hitting Control C here would bring focus there. Not quite sure. I'd have to spend a little bit more time looking into how that works. Like, if I look at yeah, I'm thinking maybe instead of set input focus, I really use the set focus function from Windows. And I know I'd have to have some kind of wrapper. But it's kind of weird that SDL wouldn't let you do that. SDL set window focus. Not input focus. Or is that the same thing? SDL raise window changes the input. Raise window. Ah, so that might be the right function. At least on this end. Let's see. Redo this change. Oh, that actually does work. From the console here now, if I hit continue, focus returns to this window, which means if I'm here and I do continue, oh no, sorry, Control C from there and then do continue, this is what happens. Control C, continue. So now I just need to handle the other direction. Now the other direction, looks like there is a way to do it. Let me just try first hacking it in and then we'll see. Okay, so I need to stick this somewhere where I can do this. Very unlikely to work. Anyway. That's true. It's not an STL window, so I can't use it here. So you have to use set focus. I hate Windows. No, see, it's not taking the focus here. Control C. It still has focus. What happened? Oh no, 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 no. I'm doing this the wrong way. What am I doing? That's not what I want. It's here. When we break into debugger, we focus on the console window. So that does not seem to work. Set focus, get console window. So yeah, I'm probably getting null. Yes, you can't steal focus from other applications because it's so doggone annoying. Microsoft finally listened to their users and blocked it. Set focus is usable for changing focus within a single application or giving away focus if you have it, but not for taking it. You cannot steal focus. Okay. Yeah, I can understand not wanting to steal focus from other applications, but this is like within the context of my own application, and I would think that it would work in this case. Not handle, but result and last error. Alright, so I get a valid handle, but set focus returns null, and alias 5. Error lookup. Access is denied. It's exactly what they were saying. You can't steal focus from application because it's doggone annoying. What about losing focus? If I just tell my window I don't want focus anymore, wouldn't that bring it? It would give it back to whatever it had before, I think. I'm guessing this won't work either. Because I don't think it's considered like I'm attached to its message queue. It turns 0 as an error though. No. So this person is actually asking the same question, and the answer here seems to imply that with a set foreground window it would work, but that's not what we're seeing. But we did see that it wasn't returning an error, so it feels like it could have worked. If the function fails, the return value is null. But it says then to get extended information called getLastError, which was what we did. It says if the window identified by hwin parameter was created by the calling thread, the active window status of the calling thread is set to hwin. Otherwise, the active window status. So, like, it's a bit weird with console windows. It's just weird that we get 0. Because it says to call getLastError if this that guy returns null to get more information, but we're not really getting any information. If the function fails, return value is null to get extended error information called getLastError. let's try this hack. Although it says here, this does not work in Windows 10 creators update. So not much hope for this. But really it's just about workflow for me. No, still returns no. But this time we actually get an error code. 87? Was that the one we got before? The parameter is incorrect. Oh, that's interesting. Let's try set focus instead of set active window. Sorry, it's harder in debug. It seems to not capture all my inputs really quickly. Access denied again. Yeah. I guess that's what we're you know, I definitely have the creators update, so if it doesn't work here, it won't work. Alright, whatever. So I won't win it in both directions, but that's okay. Gonna do something. Actually, I'll do it up here and then I'll move it. So earlier I was trying to write this find function and I stopped because it's kind of gross, right? But I don't like having this like bool here and this bool here. I kind of find that messy. I would like ideally to just do a search, right? So it'd be like find if so like if it contains an event that is this type, and if that is not equal to, and this is what I find gross, is all this amount of typing, or just this dot n I should say, and like bool, or I guess it's like if this, what the? Oh yeah, okay, just formatting. You see, that's just a lot of typing, right? But this technically should work the same way. And see, it finds it, we get back our thing. So I was just gonna make a little helper to kind of wrap this very common case of finding, like a find if in a container. But here we'll say return container. No, stood find if begin of container to end of container using the func, or I guess I'll call it the predicate, as they do, not equal to stood end of container. Now with this ugly if condition will become, I just write it below, if find if mu events lambda like that. So we say if find if mu events, so we'll go do a find if in this container with this condition. If it returns true, then we raise the event. And we do the raise window, I mean. We broke into the debugger, then set focus back to the game window once we resume. Oh, that's funny. It's funny how, like, if when I step, we can see the rendering the screen kind of go blank. Yeah. That's because my delta time is 0, so it's considered paused, and when it's paused, that's what happens, I think. Actually, I don't even know what's happening. Just happened. That was so weird. funky focus stuff happening. You know what? Forget about this. I think what's happening is that when I'm in the debugger, I don't actually remain in there. And once I continue or do anything, it does bring back the focus because we go back into the main loop. So this like hack that I have to set back the focus is no good. It's only good if we do an explicit continue. And it's not really easy to know if that's the case. So we'll forget about this for now. I'll just have to handle the focus switches myself, as I've been doing, so. Well, you learn by trying. Okay. So let me get that committed. Okay. Allow breaking into debugger when focus is on game window. Engine out passes a vector of mu events to the engine client, allowing it to handle certain high-level events, such as break into debugger based on keyboard inputs. So now that I have this, oh, hey Tsoding. I just realized that you wrote to me a few minutes ago. Sorry about that. How you doing, man? Sorry, my window was partially covered, so I didn't see the chat. So yeah, no, I'm doing good. How you doing? Tonight I'm a little bit not super like focused on what I'm gonna do, what I'm doing. I'm just kind of like picking things off my list. So, I was thinking about, now that I have this way of communicating information down, like, I remember wanting this when I was doing the pause and, well, not the turbo, but the pause, because I did all these like weird, ugly hacks, you know, like down the pipe where I look for like if the delta time or frame time or whatever is 0. Like in here, like I have like if frame time greater than 0, and I think I was the only one here, but there was definitely another one somewhere. I think I have like 2 names for them, unfortunately. I should really consolidate. Call it delta time or frame time. Yeah, here in render, in my main, I have this like if delta time is greater than 0, then we clear the lines. And then basically the idea there is don't clear it when we're paused, right? So if I'm running and I hit P, here we keep updating the render, but we don't want it to actually do what it normally does because we're in a paused state. And I feel like communicating that by virtue of the fact that the frame time is 0 maybe is a bit strange. But maybe not, you know, I guess in some way it makes sense. That's what paused means, right? We're not moving forward. It does bother me though that when I hit Control C and I start stepping, this gets darker and darker. I'm trying to think why that happens. I think it's because, let's see, debugger. Yeah, it's because I know why. It's because we're at the high level, the engine says, okay, here's the amount of frame time you're supposed to consume, debugger. You know, execute this many, execute as many instructions that fit this delta time. But when we're in step mode, we only execute 1. We don't execute as many as we can that fits that delta time. And then and so what happens is we don't actually end up, say, drawing the lines that are required for that amount of time if it had really elapsed. And then we do a render and we pass that same delta time. So it's like as if, let's say this is our delta time, we've only executed 1 instruction and then we've rendered at it as if this much time has passed. And so since we're not drawing all the lines that would have been drawn in this much time, we end up seeing the screen get dark. So it makes sense. The only real way to fix this would be if there was a way to like say, you know, this is the delta time I'm supposed to execute for, but this is how much we actually executed. You know, so if I returned the delta time for the 1 step, then that would be passed to render. But that's kind of complicated to do right now. Because this is not like it's not an in-out parameter. Like delta time is just an input to the debugger's update. But like render is completely separate, you know? So we have here at the high level update and render. And they both get the same delta time. But like I said, the one that the debugger consumes, it doesn't consume as many as it's supposed to. So that's kind of sucky. It's because it was nice when I didn't have it doing that. What was cool was I was able to say step, and I could see the results of, you know, certain instructions, what it was doing to the draw, to the render. Anyway, I'm not gonna worry too much about it, but I'll think about it and I'll think about what would be the right way to fix it, but I'm not quite sure. I don't see a very clean way. In the end, it's because I'm kind of cheating in my debugger, right? I'm not really consuming the time I'm supposed to. Now, one way would be to kind of hack it and say, like, when we're in step mode, we want to pause the debugger. But that's not correct either, because then if you just step long enough, you never clear, the screen would just never fade to black. So that's not correct either. Anyway. Okay, so I can easily rename delta time to frame time. There's only 9 hits really. Rename delta time to frame time. Another thing I wanted to do was when I plug my controller here, I think tonight we're just going to call this maintenance night, taking care of some little bit of maintenance here and there, little tasks that I was thinking about. So what I wrote here, I want to be able to pause when the start key on my gamepad is pressed. Right now I have to hit P, right, on the keyboard, so I want to see how difficult that would be. And actually it would be cool to also control turbo from the gamepad. So right now the way I have it is I have this update pause state, and that just checks the keyboard. And the way I do my gamepad stuff, trying to remember. Button down, C button equals to button down. So actually it looks like I can just use this get gamepad state by instance ID. That writes into here. Oh yeah, the complication was figuring out if I had a gamepad, so maybe I could factor this code out. Preferred gamepads for both players. If one gamepad, if one gamepad, then player 2 uses keyboard. If no gamepads, player 1 uses keyboard, and there's no player 2 input. I guess I don't have to be that specific. In my case, I can just say if any start was pressed on anything, like if P or start was pressed on any of the gamepads, then we want to pause. Gamepad states by player index. State is keyboard, and then here I say gamepad states by player index. Gamepad state is p.second. So player index to a gamepad state, which is basically this here. So let's see. Toggle pause equals to false. We'll do like this. This becomes true. And then we'll say if toggle pause. Do that. State like this. Button down. I don't have to break actually. Okay, so what is it doesn't like here? Oh, right, it's not really gamepad state, it's a pair. There you go. That wasn't so hard. Pause. Oh, okay, yeah. It's actually not as simple because while I'm holding it, it's pause and pausing, pause and pausing. It's basically doing some kind of like slow motion, so it's not that simple. I need to know if it was both down then up. Same idea as what I have with my keyboard state. That sucks. So Yeah. I can basically do the same thing I did for my keyboard, where I have a key state down and pressed. I can have here a button state down and pressed, same thing, and then kind of have this. What do I do now? Yeah, and I can do the same thing where we Right, we're going to do the same thing where we'll have a on button state change. Kind of like not the right place. This is on the button instance itself. Get gamepad state. Oh no, it is the right place. Yeah, it's because I shouldn't call this gamepad state. It should just be called gamepad. It's all right. And then we get the gamepad and we'll have functions on it. So I'm copy pasting for now, and I'm gonna see if about like factoring out afterwards if I want to do that or not. Like I might want to have some kind of just more generic, like here's a suite of functions for, might be templates or something, but just for like input states or something. Or maybe I'll have another abstraction. Keyboard and gamepad are just, you know, input devices or something. We'll see. But I'll worry more about that kind of thing later. Did I say game state? No, button state. That makes more sense. This is button states. And then we need a post frame update states. Okay. I think this is right. Yeah, that makes sense. Whoops. Damn it. Doing that. Correct all of these. Access value is okay. So here we'd say, state. For now, I'll fix this after. Okay, it's here, rather than do button down is equal to this, here we're supposed to say the button index, which is this, followed by whether the button is down. For consistency, I should totally do the same thing for on-axis state change. And what are we storing here? In 32. See this, there's a symmetry now, right? We do on button state change, on axis state change for the controller, for the gamepads, and then we do on key state change for the keyboard. So it's starting to look a bit more generic and similar. Now, having done that, I will need to iterate over my gamepad states, just like we do here for the keyboard. kvp.second. It's a gamepad state, so we do dot post frame update states. Wow, it actually compiled in the first try. That is extremely rare. Let's just see if I broke input on my gamepad. No, still seems to work. So now that I have that, I should be able to do the pause thing. So rather than look for down, we'll look for pressed. So now if I hold down start, it shouldn't do the kind of slow motion thing, assuming I did this right. Yeah. Upon pressed, it pauses. That's better. So it acts just like the P. Cool. All right, let's do a bit more cleanup now. I'll do that as a separate change. The renaming of gamepad to gamepad state. That's a little to do here. It's gonna make more sense, right? It's a gamepad, just like I have a keyboard. We'll just say it's a gamepad. These are devices. The other thing I want to do is let's do like the keyboard and hide these values and just make some accessors here. Okay, so now down here, this will be right. It was nice to be able to just access directly this way. I'm gonna have to use functions. Oh well, such is life. We'll use some fancy regex to fix this for us. Just to make sure, what I would want to do here is take this out. I'm gonna rename this gamepad and say gamepad dot get button state. Where we'd pass this in, and then we'd ask, is that down, right? Yeah. So what we're gonna do is we're gonna regex this by saying capture whatever is inside here, backslash on the square brackets, place it with gamepad.getButtonState $1 for what was captured. I think that should do it. So enable regex. Show me where you are. Gamepad state. Okay, so that takes care of the ones in here. Oh, and this one here. Why? Is it Alt R? Yeah, okay. And then for the axis value, it's going to be similar. It'll be get axis value. What, that I only had one? Oh no, I had two. Okay, so that fixes this guy. Okay, let's see if this works. Awesome. Okay. So now that I have this, I'll also be able to map the turbo button. To my gamepad. Alright, so this is just like a couple changes really. Maybe what I can do, I can like stage, I can't stage everything, but I'll unstage the part that actually does the pause state stuff. So we can say like this is the separate change for that. So I'll say refactor gamepad code to detect press when buttons are pressed. And before I do the other thing, now I can do the rename I wanted to do. It should really be gamepad by player index. In fact, it should be player index to gamepad. Which makes way more sense, as I have controller index to instance ID. How do I call this controller again? Such confusing code I wrote. Get gamepad by instance ID. I have an instance ID, and I have this thing that returns what I call a controller index. What am I doing? This is not the right name. This should be controller. This should be instance ID to controller index or player index or whatever. Because I'm searching by instance ID and I'm getting back this index, and I use that. Yeah, this is wrong. This should be let's call this gamepad instance ID to index. Gamepad. Oh, okay, yeah, okay. G controller, so G. instance ID to player index, and then player index to gamepad. So now we can go from instance ID to gamepad. And that's exactly what we want here. So from instance ID to player index, we do a find, we get the player index. And this should be G underscore. So when we do an add controller, it's because I have like this controller and gamepad. Yeah, because it's controller device added. And is game controller and all this stuff here. But then a controller gets a joystick, so they call it a joystick in SDL, and I call it a gamepad. Okay. Alright, I'm finding the key, which is the instance ID. So actually this... No. What the? What did I do? It's a game controller. I have an index here. Get the joystick and then get its instance ID. And then I'm saying for the given index, store this instance ID. So it's actually index to instance ID, isn't it? But then here I'm doing a find, and finds will search by key. This is wrong. This should be instance ID equals index. How does this work? Like, am I just lucky that I'm getting zeros and ones for instance ID and index, and that's why this bug has been hidden from me? Let's see. Yeah, that's why. It's because it happens that index and instance ID are matched. But it actually never made sense. Okay, this makes me happier. Basically, it is instance ID to index and index to gamepad. We insert inside here. It's also an unordered map. We insert this pair in here. I mean, I guess I could have done a similar thing here. So I have no more gamepad state, right? Okay, good. Again, we'll take everything except for this. And before I do the pause, I'll also do the fast forward turbo mode in the same way. Except in this case, we don't need to toggle it. We just need to know whether it should be down or not. So actually, what will I use here? I guess I could use select. In fact, what I actually would like to use is my right analog. Let me see. This value on the right analog is greater than, I don't know, 100. Get access value, is it? Yeah. I don't know the range of this value. How does it work again, this value? Is it assigned? Get access value. Assigned in 32. Okay, here's my remap. I get in32 value and I say So yeah, so it ranges from minus 32,768 to 32,767. So let's say like that works pretty well. It's interesting to note how, like, when I fast forward, the display doesn't actually do the right thing. Like, we see way too many of the lines on the render. I'm not super sure why that happens. I think it's because of the way I fade the screen to black. But I'm not sure. I'd have to figure that out. But it's not super important because in the end it's just a way to speed through the game, and it kind of even looks cool. Okay, I'm pretty happy with that. So here I'll say pause and turbo map pause and turbo to gamepad. Pause to gamepad start button and turbo to gamepad right analog. Alright, I'm going to push this. And I think I'm going to end the stream here. Just going to look at my to-do here. So I did this one. But I'm not done all the rest, so I'm going to keep it up here. Or, you know what I'll do? I'll move this one along. Okay, so there we go. A bit more of a quieter stream tonight. I didn't, maybe not as exciting, but as previous streams. But I did get a lot of this kind of, you know, little things that were annoying me. So breaking into the debugger from the game window, renaming delta time to frame time, and then all this gamepad code so that we can pause and do turbo from the gamepad. That's cool. So yeah, I think I'm gonna call it a night. So those of you who watched, thanks for watching, and I should be back I should be streaming again next week on Monday. So yeah, thanks for watching.